So for today's tutorial, I'm going to take a more detailed look at Houdini Digital Assets. These are networks in Houdini that you package up and you can either reuse within Houdini or you can use them in other programs such as Maya and Unreal. So as not to waste too much time setting things up, I'm going to reuse some of the networks that we created in earlier tutorials, and I'll save a scene alongside this video that contains these set up correctly, so if you want to follow along you can load up that scene to start with. So if you take a look at this scene, I have the very simple transform node which we created in the first tutorial, which really just consists of one node. I've also put in the little planet with trees on it, and I've included the various pieces for the chessboard. So first of all, let's look at our simplest network. So there are two ways or two kinds of Houdini digital asset you can create. First of all, there are assets that simply consist of a number of network nodes, which can be extremely complicated and include lots of nested nodes. But you would typically use this inside a network and you would use it inside Houdini. So if you have a collection of nodes that you use very often, you could package these up and just use the digital asset rather than having to rebuild them every time. In fact, you've already come across some Houdini digital assets. In fact, many of the nodes that are inside Houdini are digital assets. So I'll show you one that we've come across before, and that is the Platonic solids node. So let's take a look at that. Now, the way that you know a node is a digital asset is you'll see that it has this little lock symbol next to it. As a comparison, let's look at box node, which is no lock. And if you double click this symbol, you'll see there's another network inside. That's not something you can do with the box. So let's have a look at the network. The lock means that it's locked to disk, but if we right click and select allow editing of contents, then we can actually manipulate what's inside it, and we could change this node. Potentially we could change it and save it, and you would then have lost your Platonic solid. To get it back you would need to reinstall Houdini. A more sensible thing to do would be to make a copy and give it a different name. But for now we're just going to take a look. It's fairly straightforward to see how this one works. So if you remember, the Platonic solid allows you to build a variety of different shapes, which include a soccer ball and a teapot. You can also orient them to different axes, and you can change the scale and the position. So if we open it up, you can see, let's take this section first. So here we have the tetrahedron. So what we're doing is creating some points, moving them to 3 different positions, and then combining all those 4 points and filling in the gaps so that we have a tetrahedron shape. Then we have the octahedron, which is made slightly differently. So we have a cube. We divide it and we transform it to the correct scale. So we have all our objects built up in different ways, all built from sections of this network. If you take a look at the teapot, it actually consists of a number of subnetworks. So if we look inside the body, you can see this consists of 3 more subnetworks which build up pieces of the teapot and then brings them all together and merges all these to create a teapot shape. Now what you're essentially doing with the digital asset is selecting between these different shapes using a switch node. So the way a switch node works is you can add as many inputs as you want, and then it simply has a value of an integer which selects the input that corresponds to each number. So if you go higher than that, it'll just select the teapot. Now if we go up to the top level, we can open type properties, which is very similar to our parameter interface that we can edit here, but there's some more details. If you're editing parameters for Houdini Digital Asset, you always do it through the type properties. So here we have our parameters, and you can see that these match the parameters for our Platonic solids. So first one we have is the solid type, and if we open up our switch node, you can see that it's directly referencing, so the dot dot brings you up one level, and then we have the name of the parameter, so it's directly referencing the value in the solid type. To make this a bit easier to use, it uses something called a menu, which gives a value to a list of text. So when you select tetrahedron, you're actually selecting a value of 0, which you can see in our switcher gives us the tetrahedron object. Once we've gone through this, then we have a orientation node that changes the axis. So if we look here, the orientation node refers to another switch node. So this goes up to orient. You can see that the name of this parameter is orient, and it's selecting 1, 2 or 3. So if we go back up a level, you can see that we've got another drop down menu, and this time it selects the X, Y or Z axis, which changes the orientation. And then finally we have a transform node which uses the parameters on our digital asset to change the scale, translation and rotation of our object. So the Platonic solid is actually a very simple setup. So I'm not going to save anything here because I don't want to edit it. What I'm going to go back to is match current definition, which will switch the lock on again. And now it's protected against any changes you might make. And you could tell that it's locked because now all the nodes are greyed out. Now let's go back to our transform node and create a digital asset of our own from scratch. So there's a number of steps that you follow to do this, which are the same every time, and I'm going to put a list of them alongside this tutorial so that you can see it. I'll also put a link to the Houdini Digital Asset page on the side effects documentation, which also goes through these steps. They're pretty straightforward, so they're not very hard to remember. So the first thing you want to do is create a subnet. Now you can either go to Actions, collapse the subnet, or you can hit this button, which to me looks like a loaf of bread, but I think it's actually a picture of a box. Now, this takes your nodes and places it inside another node. So if you open it up, in this case we only have one node, but you could have a whole network inside here. The subnet has up to 4 inputs, and these are represented by these little grey numbered nodes. So if you were using more than one input, you could connect these up inside your network. At the moment we only have one input, so the number one input is connected to our transform node, and our file is connected to the first input, so effectively our file is still going into the transform node. The next step is to create a digital asset. So this gives us an option. So we have our operator name. Let's call this move to origin, and the operator label, which can be different, but I generally find it pretty easy to give it the same name, which is what it does by default. Houdini can recommend that you also attach your own name to these. It can make it a bit simpler if you have a bunch of technical artists all working on digital assets and saving them to the same folder. That way you know who's responsible. And then we have the library, and the operator name is the same as the file name. So we're simply saving a file in our library called HDA, and then the NC stands for non-commercial. So if you have a commercial version, yours will just be called .hda. So when we hit accept, it'll do two things. First of all, it will save this file, and the default file location is in your documents folder, then the version of Houdini, and inside a folder called OTLs, which is a bit confusing. OTLs are the old name for Houdini Digital Assets, and the file name is stuck around, but you'll nearly always see them called HDAs as well. It is still possible to load a file called .otl into Houdini as a digital asset. So this is where they'll be put by default. I'll show you a bit later on how to set up another folder. If you're working as part of a team, you'll probably find it useful to have a place on your network where you can share all your digital assets. The other thing it does is opens your operator type properties, which is the same as selecting type properties. So at the moment we have no parameters, and we have another bunch of settings. So some of the things you might want to look at are our subnet has now removed all but our one input, but we can increase the number of inputs if we want to. I'm getting an error now. If I change maximum inputs instead, which means that we don't have to have two inputs, see, this time it's working correctly. So now we have an optional second input, but we don't need that, and most of the time Houdini will set that up correctly for you. I have to admit that quite a lot of these I've never actually used. Some of the ones that you might find yourself using are the help, which allows you to set up help documentation for your asset. I have to admit I haven't done this very often, but it would be a very good thing to do if you're sharing your assets with a team. The handles allow you to add a huge variety of inputs, so you're looking at ways of manipulating the information inside your digital asset. For example, a HUD slider. So these are things you might like to play with at some point to get some really slick digital assets. It's possible to add scripts to your digital assets. If you take a look at the input and output labels, you'll see that subnetwork input number 1 actually corresponds to the name of this input. And you have an option to add extra files. So if, for example, your asset always used the same texture file, you could add this here, and that texture would be bundled up with the asset and always be part of it, so people who are using the asset don't have to worry about having a copy of that texture as well. Most of the work you're going to do will be in the parameters pane, which relates to the parameters, which you can see up here. At the moment they're empty. Now there's a really easy way of adding parameters. So if we take the parts of our node that we might want to access from the top level, the obvious one here is the width of our object. So all you need to do is drag it up here and drop it into the root parameters. And when you hit apply, it creates a link, which you can't actually see because this is a drop-down menu, but it creates a direct link up to this parameter. So although it looks like you're just editing the parameters here, it's actually editing this link as well. So now we have our parameters visible on our digital asset. Something which is possibly a bug I've discovered is that when you set up a menu, you want to use the token, which is these values here, instead of the label, and it seems to turn this off when you drag it up. So I'm going to turn that back on. And now you can see that we can access our different sizes from our digital asset. All the parameters are the same as the parameters that you set up here. It simply brings them up. So on our move to origin digital asset, this is really the only thing that we're likely to want to change. So we hit the accept button. So when you're working in the operator type properties window, apply will do an update without closing the window. Accept will do an update and close the window. So here we have created our first digital asset. Now the other things to remember are that we are currently working on a live file because we have an unlocked node. So if we make any changes to this, so if we were to go in and add extra nodes, then come back out again and hit save, it would update on the disk. If we don't want to change it, then we would switch to match current definition. While you're working, you want to make sure you've always saved the node type before you match the current definition, or you'll lose your changes. So it is possible to create two of these in one scene. Allow the editing of one. So if we were to create another transform node, and let's scale it down. So now you can see this one is scaling and this one isn't. That's because this is referencing the file on disk, which is our move to origin file here. But if I save this, save node type, now it instantly updates this one as well because it's referencing the file that I've just saved. So you need to be aware of which files are live, which ones are current. If you think of it as, for example, having a bunch of versions of Photoshop, each with the same file open, and all at different stages, you need to remember which one you're saving, because that's going to be the one that's saved on disk. And if you reload the other ones, then they're going to take that version. It took me quite a long time to get my head around how to manage Houdini digital assets between disks and between files, but it's actually pretty straightforward when you think of it that way. The other thing you should be aware of is that if you haven't matched the current definition, then the changes that are in here are saved in your file. So it's possible to have a file with some edits to your digital asset that aren't saved on disk. And sometimes that can be a bit of a lifesaver if you accidentally overwrite the one on disk. You can go back to an earlier file, find those changes and save those ones instead. So I said there were two basic types of digital asset. So the first one, which is creating assets as part of a network, is something that you would almost always use inside Houdini. So to make your networks more streamlined and to repeat tasks that you would use often. However, if you think about a scene in Maya or Unreal, you aren't working with networks, you're working with a scene that consists of a bunch of discrete objects. And in order to accommodate them correctly in your digital asset, you need to be working at the object level. So your digital assets that you create for other software should be created from objects. And where you're bringing inputs into them, rather than just hooking them up to the top of your node, you actually need to create a reference to other objects in the scene. And then this ties in with the way that other programs work. So probably the easiest way to show you is to set up an example, and I'll use the little planet example for this. Our little planet consists of a network that has two inputs. So first of all, we have the tree, which is our vegetation, and then we have the shape for the planet itself. Now imagine we want to set up a node that we could use in Unreal, where we can make lots of planets of different sizes and shapes using different inputs, and those planets could have different vegetation on them. So both of these will want to become inputs. So the way that we do this is we take these objects, and well, this step isn't actually necessary, but it makes it a bit easier to see in Houdini. So we take these objects and create new geometry nodes and put each object inside one of these. So we have our sphere. Let's call this planet shape. And then we'll take our tree and call it vegetation. And in place of these, we want to object merge nodes, which take a different object from our object level and allow you to paste it into this network. Now we just replace the file input with the object merge node. We'll do the same with the sphere, and we can delete these. So we go through the same process again to create a digital asset. So first of all, we create a subnet, right click, create a digital asset, and let's call this one little planet. And accept. So we have a new digital asset now. Because we're at the object level, we've got a bunch of transform nodes on here. We might want to, well, we can either hide these, so if we just select them and click invisible, they're hidden, or we can make a new folder for our parameters. So let's make a new folder and call this planet. So you see we now have a planet folder. Actually, I'm going to bring this to the top. This time, if we look at our inputs, you'll see we have none, because we're going to be inputting our files in a different way. So if we go back to our parameters, open up our subnet, and you can see that we now have access to the link inside our object merge node, which would bring in an external object. And all we need to do is drag that into our parameters and do the same for the second one. Oops. So this first object merge node is for our vegetation, so let's call it vegetation. And the second one is our planet shape. Planet shape. The difference between your name and your label here is the label is what's displayed on your top node. So if we go back up, you can see this is a label. In fact, you can have spaces in your label, so we don't need the underscore there. The name is what is referenced for your parameter inside your network. So if we have a look at that, you'll see it's referencing planet shape. It's a good idea to have these recognizably similar, otherwise it can get really confusing when you're trying to work out what's connected up at the top level. So now we have our two links as options on our top node. Let's accept and close that, and you'll see how we can hook these up now. So if we link our vegetation to the vegetation object, and we link our planet shape to the planet shape object, and you can see this is what's being brought in at the bottom. If your object isn't doing what you expect, you might want to check that you don't have the wrong node selected, because it will always render the bottom node. It's probably a good idea to put a null node on there and call it out, and then you know that that's the one that you want to be rendering. If you were to use this node in another program, you find that hooking up different objects inside a scene corresponds much more closely to the way you would be using it in a 3D modeling program. So you should be able to set this up quite easily. If you were to use a subnet, then your 3D program would probably try to model along as well as it can. But it's much easier to do it this way because it anticipates a lot of problems and it makes it easier to debug if you've got problems. So we might also want to tweak some of the parameters. So let's take a look back inside this node. First of all, open up the type properties again. And take a look at our attribute drop. We have our tree growth parameter. So we can tweak the sizes of our trees. Let's put that on the top node. So we just need to drag this up. And now you can see it's connected up to the top level. I think that's possibly all the easily manipulated attributes that we have from this. You might want to go in and add some new attributes. I find that there are two ways of setting up networks that I know will become Houdini Digital Assets that can make this stage a bit easier. One is any nodes that have a parameter on them that I know that I'm going to want to access from the outside. I make a specific colour, usually bright yellow for some reason. So you can quickly at a glance see which nodes need to have parameters changed. The second way to do it is to create a null node that sits alongside your network and set up parameters on that you want to eventually be able to edit from outside the network. It's not quite as simple as you might think, because if this isn't part of the network, you can't just drag them up onto the top node, but it does keep them all in one place, and it lets you know exactly what it is that you're wanting to recreate. So here we have our final digital asset, where I can tweak the size of my trees and I can change the inputs. That's just an example. Make a new geometry node and create, actually let's go back to our Platonic solids. Scale this up a bit and see if we can make a pyramid instead. I think we will probably need to remesh it, which will build some more points into it, and then use this in our subnet. So instead of our planet shape, let's use Geo1, see what we get. Yeah, it's slightly odd, but basically it's working. So probably we want to do things like tweak the size of the continents and give the user access to that. So lastly, I'm going to set up the chessboard. I'm not going to set up every link because I've done that already. You might remember that there's a Houdini digital asset that I created, but I'll show you how it was set up. I want to show you this one because this is another way of setting up digital asset, which actually consists of a group of objects. So this time we don't want all our chess pieces to be individual inputs, because our chess pieces are always going to look the same, and also because if you open up the chess piece, you'll see that these aren't models. They're actually, each network actually creates the chess piece, so it's starting from a curve and building it up. So we actually want to include all this with our digital asset. So this time we select the whole lot and turn the whole thing into a subnet and then into a digital asset. So this time I'm just going to call temp chess because I don't want to overwrite the asset that I already made, and I'll hit OK on that. So if we look inside here, you'll see that the asset itself contains all these different object nodes as well as the chessboard, but the chessboard is the one that's live, so that's the one that you're going to see. If we open that up, if you remember, the chessboard consists of a lot of different nodes, and these are copied to points, and it was demonstrating the group node. So each of these points is connected to a different group. For each piece on the board, we have group 1 and group A representing the rows and columns of the position on the board, and then this one will have group 1 and group H. So what we're looking at here is the rook. So we're looking at the first row and columns A and H to place them at either end. What we want in our top node is a list of, for every piece we want a list of its position on the board, and then that position can be updated using chess rotation, which allows us to move the pieces around the board. So at this point I'm going to accept and then load in our existing chess piece. The nice thing is that every digital asset that you create in your digital assets OTL folder is now available for you to access inside Houdini. So at the top level, at the OBJ level, you have all the assets that you created at the OBJ level. And one of these is the chessboard that I set up before. If we dive down, let's go into something that's we can access. Let's go into our geo node. If we go down here and go into our digital assets, you can see at the node level then your move to origin asset that we just created is available here. So there we have our pyramid being correctly placed and scaled. So if we go back to our chessboard, take the pyramid away, you can see the one that I set up earlier, which has a list of all the pieces for white and then all the pieces for black. And for each of those there is a letter and then a number representing their position on the board. So if we change this to, let's say, E4, so now we've moved our king. The reason it's set up like this is so that we can load it in an external program such as Unreal and allow the position of the pieces to be driven by code. In Unreal we would probably be driving them with a blueprint, and that way we have a piece of interactive artwork that would allow us to display a game of chess. I'll quickly show you how these are set up. So if we go to, let's allow editing of contents first, and then we can see the network inside, and then go to our properties. These are actually extremely simple. For each piece we just have a string, so this just gives us a box that we can type anything into. There's nothing stopping you typing the wrong number in, but if it's all hooked up to code then those numbers will be correct anyway. Now if we open it up, and go back to our rook, you can see that instead of a G and then a number, G and then a letter, we've got a little bit of code instead. And basically what this is doing is it's taking to link to that string, and the substring takes a character within that string. So both of these actually refer to the same string. They're both referring to rook 1, and this one looks at the second character, which is the so 1 actually refers to the second character because it starts at 0, which is the number of the row, and this one refers to the first character, which is the letter representing the column. The two little dashes tell that string to evaluate, and then it's stuck on the end after G. So what you end up with in this case, let's go back up to the top. So here's our rook 1 is G1 for the first value and GA for the second value. Those are the names of the two groups that we are looking up inside our chessboard. And when it selects those two groups, it finds the point that's inside those two groups where they intersect, and they move the object onto that point. and we simply do the same thing for every piece on the board. I'll put a copy of all these digital assets along with the tutorial as well, so that you can take them apart and have a look at them. The last subject that I want to cover for digital assets is looking at instancing. So if you were, say, working in Unreal, these assets that we've created so far would take all the geometry that's created by the assets and munge them into a single object. So if you're instancing, say, lots of trees across a landscape, then they would all become a single object within Unreal and within the game, which in some circumstances might be what you want, but in other circumstances it isn't. Say for example somebody had made quite detailed houses that then you were using Houdini to place. You would want each of those houses to remain an instance of the original object. So I'm going to show you how you would set that up. First of all, I'll put together a really simple example. So say we have a grid. So let me just drop down a grid node. And give it some details. And then we have a tree that we want to place on our grid. In fact, the tree that I used for the fairy hill in the first tutorial is saved as a digital asset. The tree isn't actually sitting in my default digital assets directory, so I can't access it directly. So I'll show you a way to bring in assets from somewhere else. If we go to File, Import, Houdini Digital Asset, you can bring an asset into the current file only, or you can make that asset directory one of your default directories. We just want it in this file. So I'll browse for the asset, which should be with my first tutorial. Low poly tree. And I'll just install it, and then it should be available to access. Yep, so there's the low poly tree. This uses a seed to generate random trees, so I'll find one that I like. That's quite interesting. So now we have a surface and a tree. The way that you create instances is you use a node specifically for that purpose, and it's a node that's at the object level, so it's similar to a geometry node. To create it, you just type in instance, and you'll see you have something that looks very like a geo node, but it has an extra tab which allows you to access an instance. The instance node is basically a copy to points node, and the way it works is you create the points that you want to copy to inside this node. At the moment it just has a small curve by default, and then the object that you want to copy onto them you attach here. So in this case we want to take our tree and tell it that we want to use the tree. It's quite easy to think this isn't working because you also need to switch on point instancing. Fast point instancing works fine in external programs. And then we want to make a surface to put our tree onto. I'm going to use an object merge node to bring in this geometry. Give it a sensible name. Let's call it grid. And then we just need to access that. We can either access the top node or the node inside. So now we have our surface. We can delete this, and we want to scatter some points across that, so we use a scatter node. We don't want 1,000 trees. Let's make it a more sensible number. So when you go back up to the top node, you'll see that our trees have been created on the grid. So if we were to turn this into a digital asset, we would make the digital asset from our instance, and then we would have the grid and our tree node as objects inside. Now for the tree node, if we're having it as an input, then we probably need another node that will bring it as an object merge that we can put inside our network, and then we can reference that from the outside. I'm going to show you how to set this up on our planet node, and maybe it'll make a bit more sense. So let's bring in our little planet digital asset and make it editable. Hide these. I need to hook it up again. In fact, let's hook it up to these objects. So we'll stick for our vegetation, we'll use the tree, and for our planet shape, we'll use the grid. There we go. So now our tree is being positioned on a flat surface, but because we're using our original little planet node, this is going to be a single piece of geometry at the end, and we want one piece of geometry for the surface, and then we want each of these trees to be instances. So open up our little planet and have a look at the network and see what it's doing. So the network, we're merging two things together. We have the trees, which are copied to points, and then we have that merged with the surface, which is this node here. And the object merge node is bringing the nodes in from outside. So now we want to go back up to the object level. So we're still inside our little planet, but up at the geometry level. And now let's create an instance node. And we can delete this. Now if we go to our original network, we're going to need this node here, which is the surface that the points are being scattered on, and then this object being brought in as the instance object to scatter on them. So to get hold of this, let's put in an object merge node, and we can just reference it. So looking inside little planet, T4 planet, it is the attribute of what node. It's not a very good name. I probably should have named it something a bit more sensible. So here we have the points in our surface which we can scatter to. And in the case of the little planet, we're just placing things on the actual points. And then at the top node, we want this object, and the easiest way to do that is grab it from here. So if we copy parameters, go to our instance node, and in the instance object we paste relative references. So we're now referencing the vegetation object that's being hooked up at the top level, and turn our point instancing on. So now we have a bunch of trees that are actually being instanced properly. Back in our planet, we no longer need any of this part of the network because this is being done through the instance node, so we can just delete it. And nor do we need our merge node. So I'll just set the out network here. So now you've have the surface being created in the original network, and then this is referenced in and used instead of the copy to point nodes to instance your object across the surface. So the little planet digital asset is now correctly creating instance objects if that's what you would want for your final asset. So if you're setting this up in Unreal, any objects that you give it as Unreal objects will maintain their integrity and be created correctly as instances. There's a lot more that we could cover in Houdini Digital Assets, but it's also a lot to take in, and I think probably that's enough for one tutorial. I think if there's enough there for you to get started on and then start playing around with some of the settings, and I'd encourage you to open them up in different 3D programs and see how you can relate what you've created in Houdini to other software. If there's anything that I've missed or any further subjects on digital assets that you want me to cover, let me know in the comments and I'll look at including them in a further tutorial. But for now, for the next tutorial, we're going to go back to looking at useful nodes you can use in your networks. Please subscribe and like, and thanks for listening.